Let's look at this question. Find employees earning more than the average salary of their department. So here you have employees table, which has employee ID, name, department ID, salary, hire date, and manager ID. And you have to find the employees whose salary is more than the average salary of their department. So the DDL and the insert statements for this table is there on my GitHub link, which is there in the description. So you can get it from there. Let me quickly jump to my MySQL instance and write the solution for this. You'll see multiple ways of writing the solution for this question. All right, so I have created this table employees. So let's try to find the solution to this question using correlated subqueries first. So let me first write the query and then we will see how exactly this query works. The very first thing I will do is select employee ID, name and salary from employees where salary is greater than, I will start a parenthesis and write a select statement, select AVG, which will help me in finding the average salary from employees where department ID equal to employees dot department ID. All right, so this is the query that will give us the answer. Let me run this query for you. And this is what the solution is. And the employee ID 1, 3, and 4 are the one who had salary greater than the average salary of their respective departments. Okay. So how it works, for each row in the employee table, the subquery computes the average salary of the corresponding department, and the where clause filters the employees with salaries greater than their department's average. One of the pros of this way of writing code is that it is simple to understand and does not require any additional table structure or joins. But on the flip side, it repeats the subquery for every row in the table, which is computationally expensive for large data sets. And performance can degrade for tables with many departments and employees. All right. So let's see another way of solving the same problem. Let me comment this and I will write another solution using common table expressions. Okay. So let me write a common table expression first, CT. So with department average salary, this is a CT that I have created. And here I will be select department ID, AVG salary as average salary from employees group by department ID. All right, so my CT is complete. Now I will write a select statement. Select E dot employee ID, E dot name, E dot salary. This is the base table. Salary from employee E. I have given it a employees E. I have given it an alias of E, and then I am joining this with the CTE department AVG underscore salary, okay, which I am aliasing as das on, okay, e dot department id, department underscore id equal to dash dot depart underscore id, where e dot salary is greater than dash dot avg salary. All right, let me run this query, and I got the same answer. Here, employee 3, 1, and 5 are the one whose salary is more than the average salary of their respective department. So how it worked? So the CT, department average salary, pre-computes the average salary of each department. Okay. And a join matches the employee of their department, and the where clause filters based on the condition. Okay. One of the positive side of this approach is that the average salary is calculated once for each department, and this improves the performance. The query is modular and easy to debug. But one of the drawback of this approach is that it requires knowledge of common table expressions, which the beginners might not be familiar with. And this approach is a bit verbose as well compared to correlated subqueries. All right. So let's look another way of writing the same solution using derived tables. I have removed the old solutions. I'll be writing the solution with the derived table over here now. So select. First of all, I will calculate the average salary for every department. For that, I will do select department underscore ID, comma, average salary, salary as average salary, salary from employees group by department ID underscore ID. Now I'll put this entire thing in parentheses. So I will enclose this entire thing in a parenthesis, and I will name this table as avg underscore table. Okay, so this is my derived table. Now what I will do is I will write select e dot employee underscore id, comma, e dot name, comma, e dot salary, salary from employees e, and then I will put a join condition over here, and the joining will happen on e dot department underscore id equal to average table dot department underscore id, and I will give a where condition e dot salary is greater than avg table dot avg salary. All right, let me run this query, and I got the same answer. All right, so how it worked, the derived table first computed the average salary per department. That was average table was the derived table name, and the main query joins the derived table to employees and filters the employees based on their department's average salary. Okay, so it gives the similar performance of what the CT solution was giving, because the average salary is calculated only once. Readability is pretty straightforward. but it may require more memory for intermediate results, the derived tables. So that is the drawback of this solution. Let's use Windows function now. So there is one more way of writing the same solution using Windows function. I will remove this solution now. I'll write the solution using the Windows function. So first of all, select employee underscore ID, comma, name, comma, salary from, sorry, I will first have to calculate the average salary. So average salary, okay, and then I will use over partition by department underscore ID, and this will be my average salary, okay. And this entire thing will be coming from employees table, all right. And this will be my subquery. I will name it as subquery, okay. Now I will put a select statement, select employee underscore ID, comma, name, salary from subquery, and I will just put where condition where salary is greater than average salary. And let's try to run this code, and it gave me the same answer. All right. So how it worked? The average salary over partition by department ID calculates the average salary for each department for each row. Okay. And the filtering condition where salary is greater than average salary is applied on the outer query, in an outer query. Okay. So one of the pros is no grouping or joins are required over here, making it efficient for large data set. It avoids creating intermediate tables or subqueries explicitly, and it is easy to extend it to calculate the additional matrices as well. Like let's say you wanted to calculate department maximum or maybe rank. Okay, so these were the positive sides of this approach. This is the best approach, I would say, for this solution. Okay, but drawback of this can be it requires an understanding of Windows function, which might be new to some developers. Since I'm using a latest version of MySQL, so that's why it is supported. Otherwise, in the older versions of MySQL, this solution will not be supported. I think below 8.0, this solution will not be supported. Okay. Now let me write one more way, the fifth way of writing the same solution using the self join. Okay, so far we have seen we wrote correlated subquery, we wrote common table expression, we wrote the same solution using derived tables, we wrote the same solution using Windows function. Now we are writing the solution using self joins. How will we do the self joins? This also is quite similar to what we have done before. Let me write the inner query first. Select department underscore ID, comma, average salary from average salary from employees group by department ID, department underscore ID. All right, select E1. So by the way, I will be naming it as E1, or maybe let me name it to E2. Okay, and the original table will be named as E1. So I'm selecting from E1 dot employee ID, employee underscore ID, comma, E1 dot name, comma, E1 dot salary. Okay, from employees, and I will alias it as E1. Now we can do a self join with the E2 table. So I will do a join over here, and here I will do a join on E1 dot department ID. The solution is same, I would say, as before. It is just that I'm introducing a concept of self join over here. Department underscore ID, where E1 dot salary is greater than E2 dot average salary. All right, let me run this, and it gave me the same answer. All right. So how it worked? One instance of employee table calculates the average salary per department, that is E2. Okay. The second instance, that was E1 that I wrote, matches each employee with their department and applies the filtering condition. The best part of this approach is it is conceptually simple and works well with grouped aggregates. It is intuitive for all those who are familiar with joins, but it can be less efficient than derived tables or CTs as it involves the joining of the same table. Now, there can be few more approaches of writing the same solution, but there is just one last thing that I wanted to show you using group by and having. How can you write this same solution? So I will quickly write this solution: department underscore ID, comma, employee underscore ID, comma, name, comma, salary. Okay, from employees. Okay, and then I will do a group by department ID. I will simply copy all these column names from here to here. Okay, and having salary greater than, then I will write a query within this parenthesis. Okay, and this will be select average salary from employee E, where E dot employee, not employee, sorry, department ID, department underscore ID equal to employees dot department underscore ID. So that's how it should be done. Let me try running this query, and it gave me demo.employee. Okay, I think I have written employee somewhere. Employees, it should be employees over here. Let me run this, and yes, I got the same answer. So how it works? Group by clause groups the data by department ID, employee ID, name, and salary. And this ensures that we evaluate each employee individually. Okay, and then the having clause. This filters the employees whose salary is greater than the average salary of their department. Correlated query computes the department-wise average salary for comparison. One of the pros of this approach is it does not require any explicit join or window functions. Okay, it uses a straightforward group by and having structure, which is easy to write and understand for those who are familiar with aggregate functions. But biggest drawback of this approach is it repeats the subquery for each group. Okay, which can be computationally expensive for larger dataset. Plus, redundant group by columns having columns, employee ID, name, salary may add unnecessary complexity, and the performance can be slower compared to the CT approach or the derived table approach or the window function approach that we just saw. All right, so I think I showed you different ways of finding solution for this question, where we were trying to find the employees whose salary is more than the average salary of their department. Hope this was useful. and you can follow me for more such contents. Thank you.